Welcome to Intro to Git for Battlecode 2023. I'm Ellington.
I'm Hank.
So we're gonna just give an overview of what Git is and important commands that you need to know, and then we're gonna do a bunch of demos. So yeah. You get to the next slide. All right, what is Git? So Git is just a version control system. It allows you to work very efficiently with collaborators, which is very important when you're with a team. It allows you to track changes to your files. And also it allows you to, it has a feature called branching, which allows you to work on features isolated from other people. Now, why should you use it? Because it makes things 1,000 times easier. I used to use Google Docs when I was in high school, and that's very, very difficult. It really increases the speed of which you can work. And it allows you to have a history so that if you make some breaking change accidentally to your code base, you have a working, you can go back, basically you have a back button. It also allows you to work independently from your team in an efficient manner. So Git and GitHub. This used to confuse me a lot, the difference between Git and GitHub. Basically, Git is like a local repository, works on your local repository, and then GitHub holds Git files for you. So GitHub is like a cloud-based interface that works very well with Git. And I think I'm going to show, oops, wait. Oh, this is not good. Wait, when I swipe, it changes the slides. It doesn't change the desktop. I see. Max. Yeah. Wait, where is it? I need a GitHub. Yeah. Yeah. All right, GitHub. This is GitHub. Yay. Anyway, so this is the scaffold that you're going to use for building a robot. This is just GitHub. This holds all your files. You can see there's all the building files. So that's GitHub. I guess I will go back. Oh, if you're gonna so to install Git, I'll just show you right now. So just type in Git, go to this website, and then you see downloads, and then Git interfaces with GitHub, so you should be fine. But if there is a problem with your Git's not meshing very well with GitHub, just come talk to us after lecture. Anyway, that's good. Okay. All right, let's download Git. Now, how Git works, actually, we're going to do demos, so let's just get to the important commands. Okay, so these are the really important commands that you should know. Other than these, everything else, I don't think it for most purposes is day to day, but all of these are very important. So clone allows you to download repositories from the web, basically copy them onto your local machine. Then when you do work, you change some files. Add allows you to take those files and move them to kind of a staging environment for when you're ready to commit them. Committing allows you to remove them, allows you to take what's in staging and move them to your local repository. And then push takes what's in your local repository and pushes it to the web so that other people on your team can see it and work with it. Pull does the opposite of push. It basically takes what's on the web and pulls it to your local repository. So if someone changes something, someone on your team changes something, and you want to have access to those changes, you can pull from the web. And then status just gives you a bunch of info about what's in your staging, what's in your local repository. So for example, if you want to know which files you've changed, and when you type in git commit, which files are going to be committed, you can type in git status for that information. And so I am going to demo. Let's see. All right. Okay, so this is the scaffold. So if you want to use this, one way you can do it, you can click use this template and create new repository. But I'm going to demo you doing it using Git Clone. So you're going to go to your command line, type in Git Clone. Oh, wait, first I need to copy the type in Git Clone. And then you've cloned it. I'm going to show you that it's there. So if you go to desktop, you see that there's now Battlecode 23 scaffold. And that's basically all the code that's from GitHub has now been downloaded to your local machine. For our purposes, we're going to use a pre-made one, which is the lecture player one, which is what I have right here. But that was just a demo of Git Clone. Wait, let me CD. Okay, cool. Okay, so let's see. I'm going to make a change to all right. So I'm gonna make a change. So I deleted an exclamation point. And now I'm going to add that change. So basically what this is doing is it adds the change to my staging. And you can see that using Git status. Wait, that is not supposed to happen. Wait, Git add you. Wait, what? All right. Yeah. Like, you want me to make it full screen? Oh. Command what? Command plus. Yeah. So Git status. All right. Why is that not staged? Git add. All right. Git status. All right. So you can see we've added this now to a staging area where from here we can commit it to our local repository. So if we do git commit dash u, or I'll write a message. First commit. Yay. And now we can see that we've changed one file and it's been committed to our local repository. So now if we want to take the changes that we've made and we want to push them to the web, we can call the command git push. And that will push them to the GitHub repository that we're connected to. Let's go here and see that. So I changed here. Oh wait, this is the wrong one. Change here. Yeah. What line was it on? 63. And here you can see on GitHub, we've also changed it. It went from hello world with an exclamation mark to now only hello world. And everyone on your team can see this. So yeah. And now I think Hank is going to change something and then I'm going to pull it. Now I think Hank is going to and then I'm going to pull it. All right. Okay. Hello world, I am at your robot location. All right, cool, cool. So that worked well. Yay. Yeah, I think that's
Okay, so hopefully you can see from that sort of how you use Git to keep track of some changes in your code. But one thing that's important to keep in mind is that you're probably going to be using Git to collaborate on a team. And as you can imagine, if you have multiple people on a team all trying to change the same code at the same time, that will cause a lot of issues. So that's where branching comes in. And you can think of Git branching as basically a way to have multiple copies of your repository so that different people can work on different things at the same time. Like you might have a branch for each person in your project, or you might want to have a branch like every time you create a new feature or something like that. So I'm going to demonstrate really quick how you make a branch. So I'm going to demonstrate really quick. Okay, so all we have to do here, so right now, if we just do git status again, you can see that we're on branch master. That's like the main branch that is created by default that all repositories will have. But let's say I wanted to make a new branch for some feature. Like let's try improving the way that headquarters build robots or something like that. So maybe we'll make a branch, git branch, building improvement. Okay, so now we have a new branch. But if we type git status, you can see that we're actually still on the same branch. So that's where another command comes in called git checkout. So we'll do git checkout. And then the name of the branch we want to check out. So building improvements. Okay, and so now we're on this other branch. And if we run git status again, you can see that we're on building improvement. So now let's go ahead and make some small changes here to make our robot slightly smarter, just as an example. So right now, we randomly choose if we want to build a launcher or a carrier, which I think is kind of silly. Maybe something else we could do instead is like alternate between having a launcher and a carrier. So we'll say if turn count mod 2 is 0, then we'll build a launcher, and otherwise we'll build a carrier. Okay. So now, same process as before. We'll just do git add dot git commit dash m, make building smarter, and then we'll do git push. Okay. So does anyone know what went wrong here? Why did this not work? Okay. Yep. So does anyone know what went wrong? Why did this not? Yes, that is the problem. And this still trips me up sometimes. But like a lot of stuff in coding and computer science, all you have to do is just copy and paste, and that will help you out a lot. So as we can see here, Git has been very helpful, and it tells us that we need to use this command here in order to make it work. So we just copy that and paste that, and it's happy now. So now we've pushed the changes to our branch. We go back to GitHub. We can see. So now I think that's the wrong one. So right now we're on master. If we went and looked at that file, it would still be the same. But as you can see now, there's this drop down here, and we have another branch that we can look at. And we can see right here that there was this new commit, make building smarter. So now this new branch is updated and it has the new code. But if we go back to master, it's still going to have the old code. So once you're done like working on a new feature, like someone in your team has finished something and they want it to be part of your main code or like the final bot that you're going to submit, then you're going to want to combine your branches back together. So you do that with the git merge command. So to do that, I'm going to git checkout master to go back to the main branch. And then I'm going to do git merge and then the name of the branch that you want to merge into master. So it was building. Okay. And now that just worked. And now if we go into master here, we should see that the change is reflected. So robot player. You should see that the change is reflected. So robot player. Where is it? Something suspicious has happened. Oh, okay. This is a good learning moment. It's also very important to git push after everything. Yeah, that was bad, but there we go. Git push. Now, if we check, hope you believe me that the change will be there. Yep, if turn count mod 2 equals 0. So now we've merged the branches back together and it's on master. Okay. So now let's maybe try see what happens when two people modify the same thing at the same time. This is an issue that you're probably going to run into. And it's a little bit scary sometimes. It's called a merge conflict when you try to combine code that will not work together. But we'll show you how you work through that. So I'm going to go back to the other branch. And I'm going to make another change that will make our robot smarter. And I'm going to make another change that will make our robot smarter. So looking through this code for the lecture player, I don't know who put this here or what they were thinking. But basically, I think it was intentionally bad. I'm pretty sure that was the intention. I think it was put here so that someone like me could come in here and fix it, hopefully. So I'm going to change this here so that it does something smarter. Right now, it just randomly decides if it wants to collect from a well or not, which doesn't make any sense at all. So what I'm going to do is I'm going to check if the robot is already full on resources. And if it is, then we don't need to bother looking for a well because it can't pick up anything else. So I'll say, well, is that length is greater than 1 and not get resource amount, adamantium. We'll just check adamantium and mana for now. Just check adamantium. So if, well, we don't really need this not. We'll just say if that is less than 40, which is the maximum amount. Just so you know, don't do this. This is called putting magic numbers in your code, and it's bad practice. So you should not just write 40 like this. Somewhere there's some constant that tells you what it actually is. Maybe I should do that. It gets game constants dot carrier capacity. Okay, yeah, that's better. So this will check if the carrier actually has the capacity to pick something up, and that's a smarter idea than doing some weird random thing. So this will check. So now I'm going to commit that change. And if you made the other change on main. So now okay. So we will add that. Okay. So now, meanwhile, while I was doing this, someone else on my team had the same idea. They thought that that random check was really silly. So they were on the main branch still, and they went and they just removed that check. So now there's nothing there. And we both think that we're improving the code and helping out, but we're going to realize that there's an issue once we try to combine our code back together. So I'll go back to main. Oop, nope, master. Okay. This time we'll get it. Okay, and then I'll try to do get merge. Building. Oh, before I do that, I want to pull the new changes. So git pull, and then I'll do get merge. Building. Okay, so I mean, this is probably a pretty silly question because I almost already told you, but what do you think is going to happen when I type this? So I mean, this is probably a pretty silly question because I almost already told you, but what do you think is going to happen when I type this? I think I already almost answered my own question, so I'll just go ahead and do it. And it gets angry. It says automatic merge failed, fix conflicts, and then commit the result. So when this happens, Git puts this stuff in your code that basically shows all the places where the code that you're trying to combine from the other branch conflicts with the code on the main branch. Make this a little bit bigger. So we can see head here. This is the branch that I'm currently on, which is master. So this is the code that's on the main branch, and this is the code that I had from the other branch. So basically, you'll have to go through the file and decide which things you want to keep from which branch. And VS Code has these handy shortcuts here that just let you pick what you want to do. So here, I'm just going to accept incoming change, which is going to take the change from the other branch and apply that. So I'll do that. And now it looks good. We fixed the merge conflict, save it. And then we actually have to commit again, just to save the fact that we fixed the merge conflict. So we do git add dot status. Okay, and we have now fixed the merge conflict, and it's all good. Okay, does anyone have any questions on the stuff we've gone through so far? Nope. All right, then I'll move on to a few more useful commands, and then that'll be it. Okay, so one other thing that's useful is git log. And that just tells you basically the history of what's happened in your repository. So if we do git log, you can see this tells us all the commits that we have. Yeah, pretty self-explanatory. And to exit out of this, you type, actually, I'm not sure how you exit out of this. I type WQ. Is this Vim or is this not Vim? I don't know. You can just type Q. Okay, that works. Okay. So that's the git log command. Now, let's do another example of something that might happen to you while you're working on your robot. So let's say you had an idea of, well, let's say you were right here and you wanted to make your debugging better and you wanted to add the location that your robot is attacking. This is in the launcher code when it decides to attack something. So we'll say, all I have to say is to attack. So let's just say hypothetically you wanted to do that. Then you walk away to go get some coffee or something. And while you're gone, your cat walks on your keyboard and it goes like this. He's for some reason types meow. I'm not sure how he knew how to do that. But he does that and then he also saves the file. And then you come back and your terminal here is covering up the code. So you don't see that anything happened. You think it's fine. So you go to commit your changes. So you do that. You don't write a good commit message at all. And then, okay. But at this point, you realize, oh, wait, this code is all messed up because my cat walked on my keyboard. Okay, so in this situation, what can you do? Does anyone have an idea? I mean, you could just delete it and commit again, but let's say you didn't know how to do that. Okay, so in this situation, what can you do? Yeah. I mean, you could just delete it and commit again. Let's say you didn't. Yes, exactly. So this is where the git revert command is useful. We'll do git log again. And we can see this commit here, the one that I just did, do stuff. So in order to revert this commit, we'll just copy the string here. Do I? Wait, do stuff. It's git revert and then the one you want to revert, I believe. Yeah, and then you do git revert and then you do that one and it reverts that one and puts it back to how it was before. Yeah, I think so. Well, we'll see if I'm wrong. Okay, so copy that. And then we just do git revert and then paste that. Okay, now we actually are in Vim and it's notoriously difficult to exit Vim, but thankfully before this lecture, I Googled how to do that. So we do :WQ. I think that's what you do. I don't know why it's like that. Okay, so now that commit should be reverted. And as we can see, the changes that I made here are now totally gone. It basically, if we go into the git status or the git log and see what happened, it's made another automatic commit here that just says revert do stuff. So it's basically just an automatic commit that does exactly the opposite of whatever you did before. Okay, so I'm going to, well, first, do you have any questions about how that worked? All good? All right, cool. So there's one more quick command that I'm going to show, and that is git stash and git pop. So let's check out the other branch. What was it called again? Building improvement. Let's check out the other branch. Okay, and on building improvement, let's say I did something. We'll just say we print hello world for absolutely no reason in launcher strategy. But then we realize that there's something that we want to change on the main branch, but we don't want to throw out what we did on this other branch. This is code that we sort of want to save temporarily because we might need it again later. So does anyone have any ideas on what we could do to save this code? Like what would happen if we just did git checkout master? What do you guys think will happen? We have some changes here. We haven't committed them. What do you think is going to happen if we try to go over to the other branch? What do you guys think will happen? We have some changes here. We haven't committed them. No one? No ideas? Yes. Well, actually, I'm not sure if we'll lose our changes. I think it's just going to get angry, but let's see. Yeah. So it says, oh, I believe it's because the branches are still consistent and it actually is able to use master here. But if you had had some other changes on the main branch, then it would not have let you do this. So for now, I'm just going to go back to building improvements. So the point is here is that you can use git stash to save the changes that you've made, and then you can use git pop to show the changes again. And that can be useful so that you can just sort of save some temporary information. So I'm going to say git stash. And now we can see that change that I made has disappeared. And then I can do anything else with this repository. I can switch to a different branch, do whatever I need to do. And then after I'm done doing that, I can just do git stash pop. And that will bring the changes back. Now we have hello world here again. So it may not be super obvious why that's useful, but I think you'll find there will be a lot of times when you're working on your code and you'll just want to sort of temporarily save something while you work on other stuff. And you don't want Git to get confused in that scenario. And basically just to store your changes away somewhere, you can use git stash. So does anyone have any questions about that? Nope. All right. So that's pretty much the end of the Git commands that we're going to go over. What happened to my slideshow? Is it hiding back there? Yes. Git commands that we're going to go over. Okay. So that's just about the end of the lecture. Although I was going to take this last minute to not advertise, but there's this program that I really like called Git Kraken. So it's very important to learn how to use Git properly in the terminal, because I think that really helps you understand what's actually going on. But in addition to that, it can sometimes be useful to have a UI for Git. So basically what Git Kraken does, and some other programs, is it shows you like a visual representation of what's going on in your repository. So if you think that sounds helpful, you can go look at it. I think there's some other ones. Yeah, so just to show an example of how that works, you can go look at it. Let's open it up. And we can see this is a log of everything that we just did in this lecture. So as opposed to like typing git log here, this is kind of hard to read, at least for me. You can go over here and it shows you everything that you've done, and you can like drag and drop and stuff like that. So yeah, definitely optional, and I would learn how to use Git properly, but it's sort of useful. So yeah, that is it for this lecture. If anyone has any questions about like setting up Git and stuff, if you're setting it up for the first time, there's some issues that you might run into. So if that's the case, then just come down to the front. We can help you with that. But that's all for today. Thank you.